This is the resistor principle you thought you understood after 4 years of middle school, but you only had a basic idea. If your physics teacher had taught it like this, you might have made it into Tsinghua University. Let me start with a question. If a resistor's function is just to turn electrical energy into heat and waste it, why do almost all electronic devices have them? To understand the reason, we need to know what resistance is. Electric current is the directional movement of electrons in a conductor, but conductors are not completely free of resistance. Different conductors have varying numbers of lattice atoms, and as electrons move, they rub against these atoms. After repeated friction, atom A becomes very hot, and electrical energy turns into heat. This is resistance. Ohm's law states current equals voltage divided by resistance. So when voltage is constant, higher resistance means less current. A resistor is a component that controls current by providing resistance. A resistor structure is simple. Resistance material is wound around an insulating ceramic rod. The type and length of this material set the resistor's value. Leads are attached at both ends to connect it to a circuit, and all materials are then encapsulated in a plastic or ceramic coating. This is the basic form of a resistor. Resistors come in various shapes, but their core structure is basically the same. Since the function of a resistor is to regulate the amount of current, why not just set the current to the desired value at the input instead of going through the trouble of using a resistor? First of all, a complex circuit contains different electronic components, such as amplifiers, sensors, and various chips, each of which requires a different amount of current. Resistors can allocate different currents to them. Secondly, resistors come in different forms and serve various functions. For example, a potentiometer lets you adjust resistance. Inside, it has a resistive track with 2 fixed terminals at each end and a middle terminal connected to a rotating knob that adjusts output voltage. As the knob is turned, the position of the sliding contact on the resistive track changes, changing the output voltage. This is what's inside a volume knob. There are also photoresistors, which have resistance that decreases as light increases. The stronger the light, the lower the resistance. Their principle is based on the photoconductive effect of semiconductors. When photons hit the semiconductor, electrons absorb energy and become free to conduct electricity, increasing conductivity. By using this effect, with components like relays, you can achieve automatic streetlight switching. There are also thermistors, which use the fact that electron activity in semiconductors changes with heat. The higher the temperature, the lower the resistance. Thermistors are commonly used in temperature controllers or temperature sensors. In short, there are many types of small resistors, and circuit engineers have even more tricks up their sleeves. That's all for this time. Did you get it?